Feel the show, sing along, let it go. We're alive, let it glow. Feel the beat, let it fall, let it fall. Move your
Let me share the screen. There you are. I'm sharing the screen. From there. You can start from there. Initial equations. Initial equations. So what are the initial equations? I think you have this handout. Initial equations. As the topic, the heading says initial equations are equations which have indices. And equations which have indices, that is to say, an equation whose quantities are raised to a certain value. Equations whose quantities are raised to certain value. Those are the initial equations. You can write down, encountered mostly in experimental observations, encountered a lot, mostly in experimental observations during research. They encountered experimental observations during research. The examples are there. You can write those examples. You can write those examples. F is equal to C L raised to A G raised to B. So, call that equation 1. Call that equation 1. It simply means F is a function of the quantity L and G. F is a function of the quantities L and G raised to certain values. Raised to certain values. So the letters A and B are the indices. A and B are the indices. To find the values of A and B, following is done. Find the values of A and B, the following is done. In this case, in this equation, actually F is a frequency, L is the length of the pendulum, and G is gravity. So the frequency of swinging of the pendulum is a function of the length of the string and acceleration G. The frequency of swinging of the pendulum is a function of the length of the string, L, and acceleration due to gravity, G. Acceleration due to gravity, G. So to find the values of find the values of A and B, the following is done. First write, look at that example. Write the NLT equation for each of those functions. Write down the NLT equations for each of those functions. So for frequency, the NLT equation is T is 1 over T. Frequency is per unit time is 1 over T, which is T raised to minus 1. NLT equation for length is just L. The NLT equation for G, meters, which is be L over T raised to 2. That equation is given there. I'll write that down, already I've gone through it. So the next step is to substitute the NLT equation in the main equation. F is equal to C raised to A G raised to B. So where there's L, you write, where there's F, you write T raised to minus 1. Where there's L, you write L raised, where there's G, you write LT raised to 2. All in brackets raised to B. Raised to 1 is in brackets raised to A, as you can see. In the equations, and then we start finding the values of A and B. Expand the equation, so the equation will become T raised to minus 1 is equal to L raised to A. And then there's also another L raised to B. And there is T raised to minus B. Then we can just write this statement, equating the like terms, equating the like terms of the equation on the left hand side with that of the right hand side. So in this case, you take on the left hand side, we only have T. So that's T raised to minus 1 is equal to T raised to minus 2B. You can see T raised to minus 1 is equal to T raised to minus 2B. So minus 1 is equal to minus B. Minus 1 is equal to minus 2B. So B basically is equal to half. I repeat that again. Putting the like terms on the left hand side, on the right hand side. In the equation you can see T is the only one on the left left-hand side. So you put that with that t on the right-hand side. So that will be t raised to minus 1 is equal to t raised to minus 2b. Then you just write the equation minus 1 is equal to minus 2b, leading to b is equal to a half. For L, there's no L on the left-hand side. From the knowledge of your maths, any letter raised to 0 is equal to 1. So you can just write this statement from the knowledge that any letter or any value, any letter or value raised to 0 is equal to 1. Any letter or value raised to 0 is equal to 1. Therefore, L raised to 0 is equal to 1. So putting that L raised to 0 on the left-hand side, L raised to 0 on the left-hand side is equal to L raised to A plus B. L raised to A plus L raised to B, which simply is L raised to 0 is equal to L raised to, in brackets, A plus B. Simply means L raised to 0 is equal to L raised to, into brackets, A plus B. So 0 is equal to A plus B. 0 is equal to A plus B. You already know the value of B, which is a half. So 0 is equal to A plus a half, leading to A is equal to minus half, leading to A is equal to minus half. So that is the case here. You can see A is equal to minus a half. There was no mass in the equation, but you can balance it. You can put the masses on both sides as is in the equation. Because we are talking about the MLT dimensions. Let's do another example. So the equation, before we go to another example, the equation would be F is equal to C raised to minus a half, G raised to a half. And then if you simplify it, you see that F is equal to C G over L raised to a half. That L minus a half, which is it's a reciprocal. It's the denominator. It goes down to the denominator. So knowing the formula for frequency of a pendulum, that C is actually equal to 1 over 2 pi. So that's what's important. Let's do the next one and see. Okay, let's do this one. It is observed that the velocity v of a liquid leaving a nozzle depends on the pressure drop P and the density rho. So we want to show that V is equal to C P over rho. So write the equation. So the equation will be V is a function of P rho. V is a function of, in brackets, P and rho, close brackets. Then if you expand it, so call that equation 1. Call that equation 1. V is a function, so you know the function sign, write the function sign. V is a function in brackets P and rho, close brackets. So if you open the brackets, you find V is equal to C into brackets P rho. Write that. So call that equation 2. V is equal to C into brackets P raised to M rho raised to B. So write the MMT equation for velocity V, pressure drop P, and density rho. So V, the MMT equation is meters per second. Velocity is measured in meters per second. Meters, which is L, per second, so it's L over T, which becomes L T raised to minus 1. Then we go to pressure. Check for the MLT equation for pressure. You have it. So the MLT equation for pressure. Let me see somebody wants to join. Yeah. That make them. The MLT equation for pressure I'm not able to admit Chariot. I've been admitting it doesn't. Something is wrong on this side. Chariot, you can come out of and then join again. Like now he can't hear me. Somebody to call him to come out and join again. Somebody to tell him to come out and join again. Chariot chorus. So we continue. The MLT equation for pressure is actually pressure is force per unit area. So the MLT equation for pressure is M L raised to minus 1 T raised to minus 2. That is the equation for MLT equation for pressure. It's equal to M F raised to minus 1 T raised to minus 2. The MLT equation for density is actually mass per unit, per volume, per unit volume, V. So mass is M, the MLT equation for density is mass, volume is length raised to 3. Volume is actually length times width times depth. All those are length. Length is L, breadth is L, height is L. So the MLT equation for density is M L raised to 3. So call that V, P, and rho as equation 3. Substitute equation 3 into 2. Substitute equation 3. Substitute the MLT equations 3 into 2. So where there is V, you write length times minus T raised to minus 1. This is equal to the same length into brackets where there's P for pressure, you put M L raised to minus 1 T raised to minus 2. So that L, you raise it to A, the T raised to B. To all that is to A, sorry. Let's repeat that. So LT raised to minus 1 is equal to C, where there is T, you now write M, L raised to minus 1, T raised to minus 2. You put all that into brackets and raised it to A. Raise all that to A. Where there is density, you put M, L raised to 3. Call that into brackets, raised to B. Then expand that equation. Expanding that equation, expand that equation, so you have C outside. Then you have M raised to L, L raised to minus A, T raised to minus 2A. Continue with the other one, so you have another M raised to B and A raised to 3B. So that will be L raised to LT raised to minus 1 on the left hand side. You can now put the letter, the quantity M on the left hand side and raise it to 0. Put the letter, the quantity M mass on the left hand side and raise it to 0. We said any value letter raised to 0 is equal to 1. So raise that to 1, to 0. So the question becomes ML, M raised to 0, L raised to 1, T raised to minus 1 is equal to C into brackets, all that. So put the like terms together. Let's start with the M. The M on the left hand side is M raised to 0, C equal to L raised to A and M raised to B. So this simply becomes M raised to A plus B. So equate the indices and write that statement. Equating the indices, equating the indices, equating the indices of the left hand side and the right hand side. Equating the indices on the left hand side to that of the right hand side. Of the left hand side, that of the right hand side. So we have 0 is equal to A plus B. If you read it like that, let's go to the next one. We have L raised to 1 is equal to L raised to minus A. And then you have L raised to 3B. So equating the indices, you get 1 is equal to minus A plus 3B. Let's go to the next one. T minus 1.
It's minus 3B.
Is equal to T raised to minus 2A. You can see on the left hand side is T raised to minus 1. On the right hand side you see T raised to minus 2A. So equate the indices. Minus 1 is equal to minus 2A. Minus 1 is equal to minus 2A, which shows that A is equal to half. So now you know A. You go back. Well, we have 0 is equal to A plus B. So you look at that equation, now you know A. 0 is equal to a half plus B implies that B is equal to minus a half. You can test it on the next equation that 1 is equal to minus a half plus A is minus a half. No, A is a half. And B is minus a half. You can test that and see if. Yeah, so you have found the value of A and B. So substitute those values in the equation 2. substitute those values for A and B in equation 2. Substituting the values of A and B in equation 2, the equation becomes P is equal to C in brackets L raised to a half and rho raised to minus a half. This simply shows that C is C. There's P, there's P. Yeah, that was P, it was not L. The question becomes is P raised to a half and rho is equal to minus. So if you expand, you get V is equal to C P over rho square root. Given to a half and rho is raised to so let's go to the next one and so update that V is equal to P raised to that. Let's go to the next one. Let's go to the next one. It is observed that the speed of sound A, the speed of a sound in A in a liquid depends on the density, rho, and the bulk modulus K. So write the equation. We start again. A is a function of density rho and bulk modulus K. If you find it, A is equal to C into bracket rho raised to A, K raised to B. And then get the NLT equations for the quantities. A is the speed, the speed of sound. So speed, of course, it is length per unit time. So A will be L t raised to minus 1. For density, as you saw, is M L raised to 3. For bulk modulus, if you check, let me take you back, you see, you cannot get it. Let's go back for, let's go to this side here, bulk modulus. You can see the last one. The last one, the NLT equation for bulk modulus is ML raised to minus 1, T raised to minus 2. Look at that and that of pressure, they're almost same. Bulk modulus and pressure are almost same. They're almost the same. So if you repeat that, you get that formula. You'll get that formula. Number 3 is the same. You can do that. Number 3 is the same. Number 3 is the same. For those who have not understood, let's do number 3. Let's do number 3. It says the frequency of oscillation of a guitar string, F, depends on the mass M, the length L, and the tension F. To write the equation, the frequency F, right, F is a function of the bracket, we have M, L, and F. We expand that, you can call that equation 1. Expand it, F is equal to C out of the bracket, M raised to N, M raised to B, F raised to C. Take the MLT equations for each of those. The MLT equation for frequency is equal to 1 over T, which is T raised to minus 1. The MLT dimensions for length is just length L. The MLT equations for force is equal to is mg. We have mass and g is acceleration, is L T raised to minus 2. Force is mg, as you all know. Force times acceleration of ma, which is equal to ma. Yeah, so substitute that into equation 2, which was F is equal to C into brackets M raised to A, L raised to B, F raised to C. So substitute there. So on the left hand side, you have M raised to 0, that would be 1. There is also L raised to 0. Then we have T raised to minus 1. M raised to 0 is 1, L raised to 0 is 1. So it's just 1 times 1 times T, which is just T raised to minus 1. So it's equal to expand, where there is a M, that was a mass. M was a mass. So it's M raised to N. So it's C in brackets M raised to N, L raised to B. F, you put now M, L, T raised to minus 2, or raised to C. Let's see how this one. So equate the like terms. Equate the like terms. For M to be M raised to 0 is equal to, on the right hand side is M raised to A and M raised to C. So 0 is equal to A plus C. Let's go to the next one. M raised to 0 is equal to A raised to B and A raised to C. So 0 is equal to M is equal to B plus C. Let's go to T. We have T raised to minus 1 is equal to T raised to minus 2 C minus 2C. On the other side, there is also L raised to B and L raised to C. Yeah. So here we just have, so minus 1 equate the indices is equal to minus 2C, implying that C is equal to 1 over 2. Now you can find the value of, you know C, now you can find the value of B. Value of B. Where we had 0 is equal to L raised to B plus C. 0 is equal to B plus C. Now you have 0 is equal to B plus C, which is a half. Now you can find the value of B. So B will be equal to minus half. So let's find the value of A. Now you know C. You know C. What is 0 is equal to A plus C. We have 0 is equal to B was minus a half plus C. So this implies that C is equal to half. C is equal to half. So substitute the values of A, B, and C into equation 2, where we have F is equal to C, M raised to A, N raised to B, F raised to C. So that equation becomes F is equal to C outside. A is a half. We found A to be equal to substitute for A, substitute for B, and substitute for C. You can see C is a half. The value of A is minus a half. So that's minus a half. We find it out. Yeah. A is minus a half. A is minus a half. From the first problem, you know C is a half. So A is minus a half. Then you have, of course, L raised to B. B is also a half, I think. And F, B is minus a half. Yes, B is minus a half. And F, C is a half. So that equation becomes F is equal to C outside in the bracket. Actually, F which is raised to a half and the others are raised to minus, which they go down. ML. So that is how we find the initial equations. That's how you find the initial equations. The values of the values in the initial equations. That's how you find the values in initial equations. Let's go to the next topic. The next topic is dimensionless numbers. Yeah, dimensionless numbers. So something doing dimensional numbers. Dimensionless numbers. We have 18 people are living from 22. So the natural numbers will do the same. In this case, we have more than 3 variables. 3 variables. Let's do. So the natural numbers. You can write this down. Mostly found from experimental observations. Mostly found in experimental observations. E.g., the Reynolds number. The Reynolds number is a dimensionless number. E.g., the Reynolds number. The fraud number, F-R-O-U-B-E, the fraud number. The Newton number. ETC, the pointer number. When you do which transfer, actually in third year, next year, you'll find a lot of dimensionless numbers. These are formulas derived by areas engineers and scientists, and which have been adopted for use in calculations. So we'll start straight away with an example. Let's see start with an example. I can see people are leaving. I think they're already on their own. So the pressure drop by unit length, for those of you who are not on, that's right, the pressure drop, you can see that when you go to it. We go to it here. The pressure drop per unit length P into friction in a pipe depends on the diameter D of the pipe, the mean velocity of the fluid in the pipe, the density rho of the fluid, and the dynamic viscosity mu of the fluid. Again, you write the equation. So in this equation, pressure drop depends on the diameter, velocity, density, and viscosity. So P, the same thing. P is a function of, in brackets, the V, rho, and mu. It's a function. So you expand that, you expand it. P is equal to C outside, into brackets B raised to A, V raised to B, rho raised to C, and mu raised to D. So we have four indices. We have four indices which we have to solve for them. Four indices which you have to solve for them. So write that as equation 2, equation 1, equation 2. Equation 1 is P is a function of into brackets D, V, rho, and mu. Equation 2, you remove the function sign, you put C, then you raise those into A, B, C, and D. So you can write this statement. To determine the values of the indices, write that statement. Determine the values of the indices. 3 of the indices are expressed in terms of 1. 3 of the indices are expressed in terms of 1. Of the indices. Then you can just write for equation 2 above, the indices A, P, and C are expressed in terms of D. The indices A, P, and C are expressed in terms of D. So we have written that statement. Now, write down the MLT questions for each of those quantities. Writing down the MLT questions for each of the quantities. For pressure, as you saw, right, for pressure is equal to MLT raised to 1 T raised to minus 1. N raised to minus 1 T raised to 1. For diameter is just a length, it's just L. For density, for velocity, you saw it's a length per unit time, so L T raised to minus 1. For mu, for rho, density, so of course M is mass per unit volume, so M L raised to 3, because there are 3 L's to get a volume. For mu, if you go back, let's go back and see what is mu. For mu, if you go up, you have this, I think. There you are. viscosity means is viscosity. Viscosity, kinematic, dynamic viscosity, it's there. So dynamic viscosity is there. Again, it is ml raised to minus 1 T raised to minus 1. So substitute this into equation 2 above. So for T, you put m raised to minus 1, T raised to minus 2 is equal to C outside the brackets D for D you just put L, so raised to N. For V in the brackets, of course, there's L T raised to minus 1 close brackets T raised to minus 1 raised to B. And then you go to density ML raised to 3, all that raised to C. Then you have mu, which is ML minus 1 T raised to minus 1, all that raised to D. Now expand the brackets, and put the like terms together. So you can just the statement, expanding the brackets and putting the like terms together. Expanding the brackets and putting the like terms together. Let's go back to the, maybe you'll see how it is done. We have done initial equations. There you are. We're doing that for example. You can see the NLT equations are there. So you have to expand. We have m raised to minus 1. Just write that. Expand and write that moment.
Let's own it. Every day is a new adventure. Feel the show, sing along, let it go. We're alive, let it glow. Feel the beat, let it fall. Move your feet, steal the show. Sing along, let it go. We're alive, let it glow. We're alive, wake up, feel the sunlight shining. Hear the city heartbeat pounding. Get up, get moving, started. Groove and dance, let's own it. Every day is a new adventure. Find the rhythm, chase the pleasure. Lights are flashing, colors blending. Join the party, fun unending. Feel the beat, let it flow. Move your feet, steal the show. Sing along, let it go. We're alive, let it glow.
To the same. So from the right hand and T, equate the like terms together. Equate the like terms together. You can start with time. There's time there. So minus 2 is equal to, on the right hand side, you have, there's T raised to minus D raised to minus D. So expressing B in terms of D, B is equal to 2 minus B. Do the same for mass. Do the same for mass, do the same for length. You can see B is expressed in terms of D, C is expressed in terms of D, and A is expressed in terms of D. There you are, just follow that. Just follow that. I know some of you have already done it. Then after getting the values of A, B, and C in terms of D, go back and substitute in the original equation. Go back and substitute in the original equation. And the original equation was, there you are, P is equal to K. In this case, instead of C, that he's using K. Instead of P is equal to C, he's using K. So there's D, A was, you can see A is minus 1 minus D. B was 2 minus D. Yeah. C was 1 minus D, and then U was just raised to D. Now put the quantities on the right hand side with numbers together, and those with these together. Put the quantities with numbers together and these together. So you see that with numbers we have D raised to minus 1, and then there's D raised to D. So there's D raised to minus 1 is there. There is V raised to 2 and V raised to minus D. So there's V raised to 2 is there, and then we have rho raised to 1, and then there's rho raised to minus D. So put those together. So we have rho, V, and D. And then you have mu, all those raised to minus D. And then in this question, we have two-dimensionless numbers. On the right-hand side, we have two-dimensionless numbers. Those raised to the values and those raised to d. So we can call the number, the dimensionless number raised to the values, call it pi1. And the number raised to d, call it pi d. Let me go back down. I wish we did this in class. This in class. So pi1 is equal to rho v raised to 2 d raised to minus 1. And pi2 is equal to mu rho raised to minus 1 v raised to minus 1 and d raised to minus 1. So pi1 is equal to that first one and pi2 is equal to the second one. So these are two dimensionless numbers. For now, you don't know much about which dimensional number is. But if you look at the second one, mu raised to is mu raised to 1, rho raised to minus 1, v raised to minus 1, v raised to minus 1. You'll find that that actually is the Reynolds number. So you can just write a statement. You can just write the statement. The dimensionless number method of determining indices, the dimensionless number of determining indices has been used to determine dimensionless numbers. Let's do an example. Let's do another example. Do another example. Let us do this one, so you can go through it. That one you can go through it. The one that has not been done. It's not there. Yeah, but you can do this example without looking at the way it has been done. Following the above method. So the trick here is to express three indices in terms of the other. And then at the end you find that some of the quantities are raised to values and others are raised to d. So those two quantities are dimensionless numbers. Buckingham's pi theorem is another method of finding dimensionless numbers. This one is another method of finding dimensionless numbers. So how is it done? So another subheading, the Buckingham, we have this, the Buckingham pi theory. Okay, again, self-explanatory. There, follow it. You find two dimensionless numbers, there is pi1 and pi2. Following the same method, Following the same method, you find some values are raised to values and others are raised to d. So those are the two dimensionless numbers. Just go through, it's self-explanatory. It's self-explanatory. I think we need to meet next week and see where you didn't understand. The example is there. The example is there. Go through it quietly. There is one exam question from this. Then you do this example. Practice makes perfect. Follow the worked out examples. You are now old enough to understand. Follow this worked out example. You do exactly the same. Follow the same procedure. There's one exam question from this, similar. At least I know there's none from additional question because it's straightforward. But for Buckingham and dimensionless numbers, there's one There's a question on each in the exam. The issue of the question is too simple, straightforward. So go through it and see. And then you have more examples. Go through them. So that will be what you are supposed to know on the mentioned numbers. Now we want to link the mentioned numbers to modeling. So the next major topic is modeling. In this dimensionless analysis, modeling is very key. Let me open another. I might not have it, but let me see if I have it. Modeling. Looking for the handout on modeling. So what is a model? Modeling. For a slide on modeling. So the next topic is modeling and prototype. Modeling and prototype. Modeling and prototype. There's some few notes here, but we're not going to use this. I'm looking for another handout which I've sent to you. Let's just go through it. Let's just go through it and see how modeling is used in dimensional analysis. Wow.
the beat, let it flow. Move your feet, steal the show. Sing along, let it go. We're alive, let it glow.